Welcome Rob Woodcock to the stage, and he's going to be talking on the Virtual Geophysics Laboratory, Scientific Workflows Exploiting the Cloud. Rob Woodcock is a stream leader in the National Geoscience Information Infrastructure and Integration for the CSIRO Minerals Down Under flagship, and he's responsible for a portfolio of projects involving computational simulation, the NCRIS-funded Odscope grid and the National Virtual Core Library, and he coordinates the flagship's activities in the Solid Earth and Environment grid. That's an e-research community advancing national and international earth science information exchange. So I'll hand over to Rob now. So, Rob, you need to watch out for this thing moves. So don't lean on it because you'll go straight over the edge. Health and safety warning, okay? You see me looking really nervous.
All right, so assuming I don't do a stage dive, so get some people down the front here who can catch me and I can crowd surf. That'd be very cool. That'll be a first for a conference, wouldn't it? Okay, so I've, as introduced, responsible for a portfolio of projects, which is another way of saying that I used to be a programmer. I no longer am a programmer, and I now am responsible for a large team who probably wonder what it is that I actually do. The only gratifying thing I've found in this process is during the last year, and I'm preambling because I can see people coming in through the door, so I'll give them a chance to get here, is that in the process of moving from Perth to Canberra recently, my team said, oh my goodness, what we're going to do, Rob's left, all our jobs are gone. So at least I must do something in terms of adding to their security and health and well-being. So that's a useful place to be. A virtual laboratory, what is it? And when we talk about them, they're not real, tangible, all right? They're virtual, that's kind of what it implies. But laboratory, what does that actually mean? Okay. So a laboratory for me is something you go to, you conduct experiments in, you test hypotheses, and it's set up usually so you can do repeated experiments, all right? So there's repetition. There should be tools that you can use and equipment that are available to you, equipment that you know how to interface with, and it is suited to the task that you're intending to perform. All right? These are the types of characteristics you have in real laboratories. They're the types of characteristics you should have in a virtual one as well. At the highest level, most virtual laboratory type projects support the following workflow: gather data, process it, publish the results. Simple, isn't it? And really, that's the challenge that's before people that are building infrastructure to support virtual laboratories, to support that type of conceptual workflow. And it doesn't really matter whether you're actually trying to add new knowledge, scientific, to the body of research that you're interested in. So you might be, for example, interested in geodynamics and plate tectonics and the evolution of the Australian continent over time. Or you might be trying to answer a more recent question like, how do I build my building so that an earthquake in Auckland doesn't cause a problem for the building that I'm dealing with, right? Or it could be even a geoscience problem associated with, I wish to dig a hole in the ground in my backyard to put a swimming pool in. Is it going to cost me $35,000 or $5,000 to dig the hole? In other words, is it sand or rock that is underneath? Town planning falls into that category for geology as well. So the types of information that we deal with laboratories is quite interesting in terms of how we use that geoinformation, how complex the problem and the scientific knowledge we're trying to discover is. In my case, I work with Minerals Down Under flagship in CSIRO within the discovery theme. So my primary use case is helping mining companies find new places to dig in Australia and ship the contents of the earth to China to turn into iron or cars or whatever it is that we buy back. All right, so it's an exploration problem out of the ground. In reality, it's actually considerably more complicated. The workflows that you're actually dealing with, the data alone is collected by a wide variety of organisations. It is a wide variety of instruments, and I've got 4 or 5 up there. Instruments include there's a lovely little shrink device. This is actually in GA's one, I believe. There's a couple in the country. I think that's actually GA. Somebody from GA's nodding, thank you. That is actually the GA one. We've got big trucks that have seismic sensors on them and seismic sources, and they go on the ground, effectively, make nice big loud noises which you detect. That tells you something about the structure of the Earth insofar as how sound propagates through it. All right? We have aeroplanes, which are basically gigantic flying metal detectors, like you'd go and buy in the shops. And they tell you something about the structure of the magnetic response of the Earth. Now notice, one said about magnetic response. The other one, the seismic one, was telling you about sound response. Neither told you anything at all about the actual rock type, all right? You could have two entirely different rock types that respond to the same sound wave in the same way, right? So a sound would not tell you any difference. The magnetics might. So you need to observe the rock and the Earth from different viewpoints to do anything useful. We have sensors. These guys, these kind of sensors are called geologists. They go out in the field, they stomp around, they actually collect physical rocks. They actually enjoy it, which I find fascinating. I am not a geologist. And we have little sensors you can stack up around the place. That's just data. All right. In Australia, data is held by the Geological Surveys. All right. There are 8 of them, one for each state and territory, and Geoscience Australia. All right. It's also held by some of the universities. The University of Melbourne has a lovely little collection they're adding to at the moment on petrophysical data for boreholes. All right. And all of it has to be part of a workflow that stores and manages it, that actually allows you to integrate it, model it, access it, and do stuff with it. This is all the stuff that needs to happen behind the scenes. All right? Ultimately, you want it to gather data, process it, and publish results. What you're actually dealing with is a community that looks like that. All right? We should have to keep that in mind. All right? So how do we deal with it within the Virtual Geophysics Laboratory? So the Virtual Geophysics Lab is a client for connecting researchers, or an application it connects researchers to data, scientific codes, algorithms, cloud computing and storage, resources, and each other. Right? It connects people together in terms of they're able to share. Its focus is on answering the following questions. What data is available to me as a researcher? How do I get it? How may I process the data? Where can I perform the processing? Where can I store my results? How do I capture and then reproduce the process that I just performed? All right? So we're talking provenance is an important part of the process. So let's begin with the simple part, data discovery. So I'll just orientate you here. That is a map. See, it's stressful, wasn't it? Okay. That is a place where you type things like Victoria. It will search the map and move it there. What? Are you just impressed by the complexity of the scientific virtual lab thing here? All right? Keep it simple, stupid, right? Okay, a little bit more interesting. Up the top left here, this is the available data sets. All right? And here we'll add some active layers. So to add some data, you select your available data set from a remote registry, and it tells you something about it. The bit that it's telling us about here is this top one here is actual data. You can go to the coverage service, if you know anything about the Open Geospatial Consortium standards. You can actually go to the web coverage service. You can ask for a particular section of the ground that you're interested in and just download that particular part of the data. You don't have to get everything all of the time. It's not download a file, it's download the bit that I want. Okay? That can be kind of important because if the coverages you're dealing with are, for example, the entire Landsat archive for Australia for the last 30 years, it's 2 petabytes of data, your iPad might die. Okay? So you do need to be able to subset and filter the data to the part you're interested in. The other part here is a web mapping service. A bit like the iPad may die for downloading, sometimes all you want is the thumbnail, the picture, the one that appears on the map. So a portrayal service is a handy thing to have. The underlying infrastructure knows that both of these exist. All right? And that they're related to the same concept. So we know, for example, that this is the onshore-only geodetic data set, magnetics, gravity data, and that these 2 services are pointing to the same underlying collection. All right? It's the same data, just in 2 different ways of looking at it. Once you've selected some data, you can actually select a subset. You can actually ask, for some of the data is actually quite intelligent. The data services can actually ask you, would you like it reformatted? Would you like it as a CSV? Would you like it as a NetCDF file? Would you like it as GeoTIFF? okay? And it will actually do the conversion and provide it to you in the format that you would like. That's kind of neat. Some data, though, isn't so smart. So there are different levels of compliance and different maturity levels available within the infrastructure for accessing the data. This one is an example of a 3D model. As you can see, it's got rich metadata with source, title, abstract, keywords, contact organisation. There's in fact more information available from the actual metadata record than we ever display in the portal. All right, so you can actually find out a lot more. This one comes from Geoscience Australia, which is kind of cool. And there's a set of links at the bottom where you can actually download the individual files that make up that particular data set. All right? I would say that that's slightly better than no metadata and just a bunch of files. It's discoverable, but it's a fairly low level of maturity. It's not like the previous one where you can actually ask for a subset. You can't subset this model. And we say nothing about what's inside the model in terms of you can't query within the model, which is can be a little frustrating. So the different levels of maturity in here. Now, what's interesting is it's all hidden, but any of you that have been following what's been happening with NCRIS in Australia over the last 5 years might begin to realise that something interesting just happened, in that we just accessed some data, in this case some 3D models from GA and a gravity data set. I could, through the exact same infrastructure, access every borehole that's been scanned so far by the geological surveys in every state and territory. I could access the chemistry information from every state and territory. I can access the rest of the radiometrics and the magnetics and gravity data, the Landsat data from all of these organisations. And in fact, it's entirely possible to ask exactly the same question to discover what data sets are available, exactly the same filter query against all of the chemistry data sets. I could, for example, pose against the borehole data sets at every geological survey. Could you please show me or provide to me all the boreholes that you have that fit within the polygon map of Australia that are at the depth of between 150 and 300 metres, intersect two rocks that have a spectral signature that is equivalent to dolerite rock type. All right? That same question can be asked of all of the geological surveys, and I will get back a result that is in the same format, despite the fact that all the surveys hold that information in a different form. All right? That is stunning, and it is the result of a hell of a lot of work by the geological surveys, under the auspices of the NCRIS and the AusScope activities, by the CSIRO, by GA, by the University of Queensland, by Monash, by the University of Melbourne, and the list goes on. In fact, you'll find I've deliberately not put a logo slide and an acknowledgement slide because it would be the entire talk. All right? We need to realise that previously to get that same query to respond to can take anywhere between a month and 12 months to reconcile all of the vocabularies that are associated with the data. All right? This portal takes all of that for granted. All right? And I just really have to bring it out because you don't see it in the virtual laboratory. It just happens. That is why NCRIS started up. It is why AusScope as an infrastructure existed, and it's actually working, and it's operational in the public sector agencies that hold the majority of the data we want for the geosciences. So much so that the technology stack that's been used at the bottom of it, which is called the Spatial Information Services Stack, we gave it another name, not AusScope, because it began to be used in other domains, including environment and water, marine, groundwater work, and, of course, the work with geology and geophysics. All right? That is a credit to the community and the effort that has gone into the whole of the NCRIS super science initiatives and so forth. So it's a message I wanted to make really clear if I haven't done so already. So what just happened behind the scenes is you've actually had the portal take a look at the registry to discover what data was available. The registry can be distributed, but it's basically gone out and said, excuse me, but of this community that is participating, so the AusScope community, what data do you have available to me? The services themselves are self-describing, so that metadata is actually harvested from the services. All right, so if somebody stands one up, all they have to do is say, my service exists, and the registry will go out and grab the metadata. Nobody has to type it in manually into the shared registry component. The VGA will actually build the data request, but will not get the data apart from the bit that you can see on the screen for portrayal purposes. All right, but at this stage, it hasn't actually moved any data anywhere, which is kind of important because we're going to process it. So from this point onwards, we're not dealing with mature infrastructure. We're now dealing with processing services infrastructure. And how do we go about maturing it? So from this point onwards, the virtual laboratory is now an experiment in and of itself. How do you build these effectively? So some of the things we've been looking into doing is providing a variety of toolkits. These are toolkits that can be used together. In this case, we have things for geophysical inversion. We have eScript for doing various forms of geological modelling and simulation, again, and Underworld similarly for a different type of geological modelling. In fact, they can do the same things and they can compete. This is because this comes from two different research groups, one at University of Queensland and one at Monash, but they're cooperating at a level that allows them to access the data and move it along in the workflow. So we're looking at making these toolboxes available. They're actually already installed into virtual machine images, so you can spin up as many as you like. We're working pretty closely with Ben Evans and his team at NCI and the Nectar crew in order to actually make that a far more configurable and appropriate process. We have high hopes for Puppet and Friends, which you would have heard mentioned if you heard Ben's talk yesterday. The files that are quite large in some cases that you selected from the website are actually ready to go. This one's not actually downloaded. It says service call to a particular server. It's not actually moved any of the data. It's just stored everything you said for the bit that I selected. I just want that part of the map, and it's just stored away that that's what you're going to use. It doesn't move the data yet, partly because the system might actually know that the data's on NCI, and there might be a faster way of staging it in, so you having to do the work. And small files, on the other hand, you can actually upload yourself. Right, so easy enough. You select a small file, upload it, off it goes. It stores all that information away. The actual workflow, we haven't used a visual programming environment. We don't use little boxes and arrows. We actually use Python and a couple of other languages to help allow the user as much flexibility as possible. Some of these codes are not amenable to visual programming in my view. They're just the way in which you bring things together is just too complex. You might as well be using a proper programming language rather than being constrained by a visual workflow. That's no offence to visual workflow. It has its appropriate place. This is not one of them, in my perspective. So we have instead, what we've done is we've got various templates and libraries to allow people to share the code snippets they're using for processing stages. All right? And that way people can continue to build, or communities can build on their stuff. And one good example is in Geoscience Australia. There's one geologist, geophysicist who's very good with inversion, quite happy to code, actually has a double degree in computer science. He creates pieces of snippets of code, and his colleague who sits across the cubicle from him, who doesn't have a double degree in computer science and geophysics, just wants to use those codes, uses his codes. They're shared through the portal. He gets the most up-to-date version all the time. If he needs to tweak it to make it divide by 2.1 instead of 2.2, he can do so without too much effort. And the guys, I didn't actually know that my team had done this, they actually added the ability to have little user interfaces that can pop up to make life a little bit easier as well if you wish to. So you can build these things from the existing templates, get in there and edit them. What happens behind the scenes is eventually VGL will actually call or stage that job to the cloud. It'll spin up the virtual machine. It'll begin the processing place. It will have grabbed the user scripts and input files from the cloud storage. It'll download any big data sets that were not previously downloaded, because you don't want the 2 petabytes on your desktop machine. You want it at the actual server, so it'll go and do that for you. It'll perform the processing, it'll upload the results, and you get very excited because now you've got your results. And you write your paper and that's it. No, that's not it. I said a laboratory should be repeatable. All right? So what the Geophysics Lab encourages is internally it's actually tracking all of the things that you're doing. Right? It's checking all your input files, your output files, and so forth. In effect, it's creating a provenance record. So all of the jobs' outputs are accessible, all right, to you or to your friends in time. And successful jobs can have their entire provenance captured. In this particular case, we're using ISO 19115. All right? And anybody that knows anything about provenance and ISO 19115 will go, as they should. Right? It's not entirely great. One of the reasons why we've done it this way at the moment is the original prototype was actually used within a public sector agency, Geoscience Australia. And one of the things that comes out of this for them is actual products, which they will put up on their website for industry and others to use. When they go to do that, they actually publish an ISO 19115 record, so it's a publication metadata record, which will go out to ANZ and Research Data Australia, so you can find it. So that all happens behind the scenes automatically, all right? But the last step of going from, I've done some processing by the researcher, to here is my product requires a handover of the metadata to a different group for publication purposes. If you make those two incompatible, then somebody has to write the conversion, if at all possible. So we actually chose to make them the same to see what would happen. All right? And that way the publication can go out with its provenance information. It's not perfect, and there's still lots of work to be done. All right? And there's whole research projects on that area, which we're now getting involved with. Once you've got the provenance, we actually publish it into the catalogue directly, so you can get it from GeoNetwork. It could technically go out to RDA. We'll just skip this bit because it's boring. Under construction, what's left? Lots of things. Lots and lots and lots of things. Bring your own cloud allocation. At the moment, we don't have a good way of knowing that this particular user has access to 5 clouds with these many resources. So there's a bit of a challenge there for us to sort that out. When a user comes to the system knows about certain clouds. It would be better if it could actually just use the clouds you bring with you for doing processing. Confidential data, how do you access it? And this is all actually an authorization issue. AAF, great for authentication. The authorization issue has been brought up a number of times during various virtual laboratory and other Nectar-related talks during the day. And we have to watch out where you can store the results as well. Oop, apparently I'm finishing. That's it, that's good. And also just running massive jobs. Ultimately, we'd like to see if we can develop, and this will come up, I think, in the Nectar Cloud discussion this afternoon, see if we can come up with a way of creating a common processing services platform. And by that, I don't mean necessarily a technology. The Spatial Information Services Stack has achieved the status within the whole of government that it's actually been selected as a reference implementation and a design pattern for the National Plan for Environmental Information across government. It's used in government agencies on an operational basis. All right? It's that level of achievement. And it's interesting because SIS itself is a bunch of open source technologies. All right, it's a collection of things. But when you people started to refer to it by a single name, and it was the way of working as much as the technologies that were in use. And in fact, you can use alternative technologies and still have the same way. And I think as we move into laboratories and analytical services, we need to start developing the same type of common understanding of what that practice actually is and how they actually work together. And so we ultimately have a vision where we can actually scale up out of the weeds of individual disciplines and individual laboratories like this and get right up into the point at which we're doing integrated virtual labs. And the people that are working on those no longer need to know about the underlying details of how the bits that they're building upon are done. Because if you have to know everything, we can't scale as a community. All right? Importantly, we can't scale to answer questions like that one. How do we have sustainable resources, water, energy, all of which require more disciplines than I will ever be able to learn, for example. And that's where we've got some challenges to come. Thank you.
So do we have some questions? Probably take one or two before coffee. Those of you upstairs, there's a couple of microphones.
So you mentioned that all these various services self-describe their data.
Yep.
How do you deal with academics wanting to use their own language to identify their own resources and, somehow arrange for a Rosetta Stone or equivalent?
Okay. So there's actually a talk this afternoon, which I'm giving on behalf of Simon Cox on a vocabulary service, which is related to that issue, so I'll just point forward a little bit. But also, there are different compliance levels. So we have a concept of a data maturity model. It applies equally well to data as well as it does to services, which we're still working through. That helps people discuss what level of compliance they've reached. One of the reasons for the use of the upload facility and the use of Python, for example, is because the data sets that are actually provided by the geological surveys, the public sector agencies, okay, they're like in that lovely pyramid that Cliff used with the EarthCube talk yesterday. They're like community Uber reusable data, right? So those things have got semantic modeling and everything else up the wazoo because they're going to be used by everybody, all right? That's the idea, broad reach, all right? A researcher will know their data, doesn't need to necessarily share that, right? So there's compliance level 0/-1, all right, and there's compliance level up the wazoo kind of thing. And so we talk about things in that context and allow people to contribute at the level necessary for their particular purpose, all right? And as long as you can actually say, I'm compliant to level blah, and here's my vocabulary, or call me, take your pick, right? Then you're all good. So it's done by that type of process. It still needs work, and the vocabulary service is part of that this afternoon.
Great. Any more questions?
Everybody wants coffee, which is good.
Yeah, that's right. I might just ask one last question. It's just a data issue. So if I do a run and I get a result, or I don't get a result because something broke, how do I sort of track back to the owners and get the problem fixed? And I can imagine that's going to be a pretty...
Well, yeah, certainly error logging and checking in a distributed and federated system is a bit of a challenge. Where possible, the thing actually keeps track of pretty much everything. The bit that I skipped is actually the job status checking and so forth, so you can actually check and see where your job got to and why it stopped as best it can. And there's an error passing system that will actually pass back some of the logs, if they exist, to get the answers. But sometimes things just disappear.
And so can I pose interesting questions to your new geophysical lab, such as, please find me a ton of gold?
Well, actually, that's oddly enough why some people are using it, because that's exactly what they want to do.
So look, at that point, we'll thank Rob for a wonderful talk, and we'll end this session.